Today we are going to solve exponential and logarithmic equations. We're going to start with exponential, specifically exponential involving e. Anytime you have an exponential equation, you want to get whatever is raised to the exponent by itself. So e is being raised to the exponent. We need to get e by itself. How do we get the 2 away from the e? Divide by 2. So we have e to the x equals 6. Before we knew anything about logarithms, we would now have to basically guess and check. We'd have to try to plug numbers into x and see which ones got us close to 6. But we have logarithms now, so we are able to change forms. Anytime you're stuck with x in the exponent, change forms. That would be the log ride, the woo. So 1, 2, 3, woo! This is log, because we're changing it from exponential to logarithmic. So log base e of 6 equals x. Remember that woo, that curly Q log ride, shows you what order you are going to write the numbers when you rewrite it in the other form. Does anyone remember from the last half of the chapter what log base e is the same as? ln. So you may want to jot somewhere in your notes, remember that ln of a is the same as log base e of a, or any other letter that you decide to use. ln of 6, that is something that you can do in your calculator. Doesn't matter what type of calculator you have, as long as it's at least a scientific calculator. ln button, 6, and it says 1.79 approximately. Now the directions say correct to 2 decimal places. That means 2 places after the decimal. I've been pretty lenient on quizzes and tests when it says specifically how to round, when people don't necessarily round in that way. On the test, I am going to be pretty picky about it. If it says to 2 places after the decimal, make sure you round it to 2 places after the decimal. Please try this second one, 4e to the 3x equals 20 on your own. Pause the video, give it a shot. Divide both sides by 4. Then we have e to the 3x equals 5. Change forms. Woo! Log base e of 5 equals 3x. Log base e is the same as ln. So we punch in ln of 5 is 1.61. And then we need to finish this off by dividing by 3 to get x completely by itself. So 1.61 divided by 3.54. Okay. On the next slide, we're looking at an exponential equation that doesn't have e, exponential equation with numbers. You still need to get whatever is raised to the exponent by itself before you do anything else. And when you're solving this type of equation, always add or subtract before you divide. So we're going to start by adding 2 on both sides to get 2 times 5 to the x equals 32. Next we divide by 2 to get 5 to the x equals 16. We're now stuck. X is stuck in the exponent. Before logs, we'd have to guess. 5 squared is 25, so it can't be 2. It has to be something less than 2. We'd have to keep guessing until we figured it out. But now that we have logs, we can change forms. Woo! Remember, you start by writing log. 5 is the number you start with. That's the little number that goes in the base. The next number you write is 16 equals x. I did that last hour too. That was my calculator falling to the ground. Log base 5 of 16. If you have a fancy newer calculator, you can do alpha window 5, and then your calculator gives you this fancy little thing like this, And you can fill in the 5 in the little box and the 16 in the big box and get your answer. If you have an older calculator or a scientific calculator, you can do this using change of base. That would be doing log button 16 divided by log button 5. If there's parentheses, you need to make sure you close those parentheses in the calculator. So log button 16. 1.72. So 1.72 equals x. I'd like you to pause the video and try this one on your own. It looks a little bit different, but it's really the same. Divide both sides by 8, change forms, see what you have at that point. Pause the video, give it a try. Okay, divide both sides by 8, you get to this point. Now we need to change forms. Woo! Log base 3 of 5 equals x minus 6. Before you do anything with the minus 6, figure out what the left side is. So either alpha window 5 and then type in the 3 and the 5, or log button 5 divided by log button 3, because you really can use any calculator to do this. Can you? You really can. Well, I mean, as long as it has a log button on it. 1.46. Now that you know that log base 3 of 5 is 1.46, now we can add 6 to both sides to get our answer, 7.46 equals x. Now we're going to switch into solving logarithmic equations. So we were solving exponentials by switching it into log form. Now we're going to solve logs. We're going to solve logs. We're going to solve logs by switching into exponential form. So take a look at B. Do you see how there's a 2 in front? Yeah. You would want to get ln of 3x by itself before you changed forms. In A, it's already by itself, so we're good to go. We're basically stuck. X is inside the log. You cannot subtract 2 on both sides because plus 2 is stuck inside the log with the x. So we need to change forms. Start with your little 3 and woo! Now remember, this is log form. You want to change it into exponential form. So 3 raised to the second equals x plus 2. What is 3 squared?
6.
9. 9 equals x plus 2. So what is x?
3.
He's lying again. 7.
Wait.
Welcome to my class. There's something.
No, that was 7.
Okay, now this is something that really, that really needs to be said. With logarithmic equations, if you try in your calculator right now to push log button -10, your calculator will give you an error. You cannot do logs of negative numbers. So when you're solving a logarithmic equation, we need to check, would this x value make the stuff inside the log be negative? So 7 plus 2, that would not be negative, so we're fine. All right, let's try this next one. We divide both sides by 2 to get ln by itself. And since this is probably going to be a decimal anyway, I'm going to do 3.5 for 7 divided by 2. Okay, you need to remember with ln, you need to remember what ln stands for. ln is the same as log base e. I think we wrote that on a previous slide already. So anytime you see ln, you can either rewrite this as log base e, or just for laziness, just stick a little e right there to remind yourself that ln means log base e. And now change forms. Woo! E raised to the 3.5 equals 3x. Where is e on our calculator?
Right here.
Right here. That tells the people in the video a lot. It's above the ln button. ln is base e. E and ln are very, very tightly related, so you push second ln to get your e, and then type in the 3.5. E to the 3.5 is 33.12. And what do you suppose the last step here is going to be? Divide both sides by 3 to get 11.04. Because this is a logarithmic equation, we need to check. 3 times 11.04, would that be positive? Yes, so that answer is fine. In example 5, we have 2 logs on the same side. So this is going to connect what we did yesterday with what we are doing today. Yesterday, we expanded and condensed logs. This has addition between the logs. Addition between the logs condenses down to multiplication inside the log. So we rewrite this as log base 6 of x times x minus 5 equals 2. So step number 1 is to condense so you only have one log on the left side. Step 2 is then to change forms and simplify. So 1, 2, 3, woo! 6 squared equals x times x minus 5. 6 squared is 36, and we can distribute to get x squared minus 5x. Anyone have any guesses what we're going to have to do next? It's possibly our favorite thing in the world to do. We're going to have to factor. So we want to get 0 on one side so that we are ready to factor. So get 0 on one side, factor, and solve. We are looking for 2 numbers that multiply to give us negative 36 and add up to negative 5. So 1 times 36, 2 times 18, 3 times 12, 4 times 9. To add up to negative 5, the bigger number needs to be negative. So my solutions are negative 4 and positive 9. Okay, remember we have to check. With logarithmic equations, we have to check. And you're not going to check in our first step, you're going to check back in the original problem. What happens if I put negative 4 in place of this first x? I have a log of a negative number, and we can't have that, so that's an extraneous solution. If I try 9, log base 6 of 9, that's good. 9 minus 5, that's positive, that's good. X equals 9 is our final solution. We are going to skip example 6. If you need help with example 5, let me know. Example 7, this time we have 2 logs and they're on opposite sides. This basically says ln of stuff equals ln of stuff. The 2 sides of an equation have to be exactly the same. They have to be equal. That's why we use an equal sign between the 2 sides. So if they both are ln, then what has to be true about the stuffs? The stuffs have to be equal. So basically the ln's cancel each other out, and you're left with 3 minus x equals 10. Anytime you have logs or ln's on both sides, if it's log of stuff equals log of stuff, stuff equals stuff. And then you would quickly solve this and get x equals negative 7. Whoa. Now check. If you put negative 7 in here, 3 minus a negative 7, that's the same as 3 plus 7, and that would be positive, so it is actually fine. A negative answer is not necessarily an extraneous solution, you have to check to see if it would create a negative inside the log.